In this video, we will be studying mean absolute deviation. On a high school basketball team, we are asked to help the coach decide who should win the Most Valuable Player or MVP award. The only data we are given are each player's point totals from the last 5 games. They are listed below. Michael scored 10, 14, 11, 15, and 10 points over those 5 games. Austin scored 4 points, 31 points, 6 points, 18 points, and 1 point. Well, to help the coach, the most obvious choice, or the most obvious thing that we should do is to look at the data and look at the points and add them together and see who scored more, see who helped the team score more points. So when I add all these together, Michael comes to a total of 60 points. Now I add Austin's points, and he also scored 60 points. So this is going to be a tough decision of who is more deserving of the MVP award. To better help us make a decision, we're going to find the mean absolute deviation. To begin, we're going to place all the data from Michael's points over those 5 games into this table: 10, 14, 11, 15, and 10. And then I'm going to find the mean of that data. Now, on the last page, we went ahead and added all of the data, all of his scores, and we realized that he scored 60 points over those 5 games. And to find the mean, we need to divide by how many data points we had. Well, 10, 14, 11, 15, and 10 are over 5 games, so we will divide by 5. 5 goes into 6 once. 5 goes into 10 twice. We have none left over. That means that the mean is 12. Next, what we need to do is find the distance of data point from the mean. So how far is the data from the mean? How far is each game's points away from the mean, or the average number of points that Michael scored? Well, in the first game, he scored 2 points away, or 2 points below his average. In the second game, he scored 2 points above his average. In the third game, he scored 1 point below his average. The fourth game, he scored 3 points above his average. In the last game, he scored 2 points below his average. We were just trying to find the distance, and distance is always measured with positive numbers, so we just counted the number of steps, or the number of points away from the mean. The next thing that I need to do is find the mean of the distances away from the average. So I need to find the sum of 2 plus 2 plus 1 plus 3 plus 5, which gives me a total of 10. I now need to write down how many data points we had, which were 5 data points. And now I need to divide 10 divided by 5, which gives me 2. That means that the mean absolute deviation for Michael was 2. We'll talk about what that means in a moment. Let's move on to Austin. For Austin, we're going to place his data into this table as well. Austin scored a total of 60 points over those 5 games, which gives him an average, or a mean, of 12 points per game. So he averaged 12 points for every game, just like Michael did. And now I need to find the distance from the data, or from each game, away from the mean. In the first game, he scored 8 points below his mean, or 8 points below his average. In the second game, he scored 19 points above his average. In the third game, he was 6 points below his average. In the fourth game, he was 6 points above his average. And in the last game, he was 11 points below his average. What I need to do now is add up all those distances. 8 plus 19 plus 6 plus 6 plus 11 gives me a sum of 50. And there were 5 data points. So 50 divided by 5 gives us a MAD, or a mean absolute deviation, of 10. When trying to compare the original question or answer the original question, who is more deserving of the MVP award, you remember we first tried to find the total points scored to give us the answer to our question. But since they both scored the same amount of points over the same number of games, that made it difficult to do. So then we looked at the MAD, the mean absolute deviation. For Michael, it was 2. For Austin, it was 10. What mean absolute deviation means, what it stands for, is the average distance away from the mean. Well, since Michael's mean absolute deviation was only 2, that means that Michael is a more consistent player. His scores were much closer and uh, much more the same every game, while Austin, his points were scattered all over the place. One game he might score 4 points, but then another game he might break out and score over 30. And so you didn't really know what you were going to get with Austin, while with Michael, you know exactly what you were going to end up with. You knew he was going to score 10 to 15 points every game, but Austin may have scored 1 or all the way up to 30 points. And so when it comes down to it, we're going to help the coach decide who the most valuable player was, and that was the player of consistency, Michael. We have now added a new measure of variability called mean absolute deviation. It also helps us measure spread and how spread out the data is, or how close the data is, shows consistency. And the more we know about measures of center and measures of variability, the better we can support our stances, especially if we're trying to give advice to a coach.